The number of hydrogen ions in 4.9 grams of tetraoxosulphate 6 acid is dash. Solution. Now let's write the ionization equation of tetraoxosulphate 6 acid, which is H2SO4. So we have H2SO4 to give hydrogen ions and sulfate ion, that's SO4, and the charge on it 2 minus. Now this is not balanced yet. To balance that, since we have 2 atoms of hydrogen present, so we'll be adding 2 here, so this makes the equation balanced. So after writing the balanced ionic equation, the next thing to do now is to calculate the number of moles of hydrogen ions present in the acid. We'll be calculating the molecular mass of H2SO4 first. So we have So to do that, we'll be summing up the atomic mass of each of the elements present in the compound. So here now we have 2 atoms of hydrogen present and the atomic mass of hydrogen is 1. So we'll say 2 times 1 plus atomic mass of sulfur is 32 plus, for oxygen now we have 4 atoms of oxygen present and the atomic mass of oxygen is 16. So we'll say 4 times 16. So this gives us 2 plus 32 plus 64. And this gives a total of 98 grams per unit. So now, coming back to this equation now, so we can see that 98 grams of H2SO4 contains 2 moles of hydrogen ions. So now, if we are given 4.9 grams of H2SO4, how many moles of hydrogen ion will be present? So 4.9 grams of H2SO4 will then contain X moles of hydrogen ion. Don't forget that the first thing we want to do is to know the number of moles of hydrogen ion present before calculating the number of the hydrogen ions itself. So now here X will then be equal to 4.9 grams multiplied by 2 moles divided by 98 grams. So here we have 9.8 divided by 98 and the unit moles, which gives us 0.1. The unit also moles. If 98 grams of H2SO4 gives 2 moles of hydrogen ions, definitely 4.9 grams of H2SO4 will give us 0.1 moles of hydrogen ions. So now the next thing now to do is to calculate the number of hydrogen ions present. What we did now is just for the moles of hydrogen ions present. So the next thing to do now is to calculate the number of hydrogen ions present, and to get that we'll be making use of Avogadro's constant. According to Avogadro's, 1 mole contains 6.02 times 10 to the power 23 ions. It can also be particles, it can be atoms, depending on the question given. It can also be molecules, but Avogadro's constant is just 6.023 times 10 raised to the power 23. So whatever we'll be having in front of it, whether ions, molecules, particles, atoms, will depend on the question given. So here now we are dealing with number of ions. So we'll just put it that if 1 mole contains 6.023 times 10 raised to the power 23 ions. So Avogadro's constant Then 0.1 moles of hydrogen ions will contain X ions. I'm using X here to serve as an unknown and to also make it very easy for us to understand. So now here now we'll be cross multiplying indirectly. These words contain will be taken as an equation sign. So now we'll be cross multiplying to get X. Now this and this will be going together, then this and this will be going together. I want to believe you understand that. So now to get X, now we'll then say X equals 0.1 moles multiplied by 6.023 times 10 raised to the power 23 ions divided by 1 moles. So solving this now, we have X to be equal to 0.6023 times 10 raised to the power 23 ions. In standard form, this is also equal to 6.023 times 10 raised to the power 22 ions, which serves as the final answer. So with what we just did now, we've calculated the number of hydrogen ions present in 4.9 grams of tetraoxosulphate 6 acid, which is 6.023 times 10 raised to the power 22 ions. And that will be all on that. Kindly subscribe to this channel and also click on the notification bell so as to be notified as soon as new videos have been posted. Thank you.